it's expanding. It's not a shrinking rectangle like the shrinking circle. It's an expanding rectangle. So that's much more exciting as well. Expanding rectangle.
Number again?
Number 12. You're correct. Thank you for that. Number 12. A rectangle initially has dimensions 2 by 4 centimeters. A 2 centimeter by 4 centimeter rectangle to begin with. Oh, I ended a preposition. It's horrible, isn't it? So now what happens? All sides, it says, all sides of rectangle begin to increase. All sides begin increasing at a rate of 1 centimeter per second. What is the rate of the area and what rate is the area increasing after 20 seconds? At what rate is area of rectangle increasing? They say after 20 seconds. They don't mean at 21 seconds because it's after 20. When they say after, they really mean at 20 seconds. I don't know what buffoon created that problem, but whatever. All right. Who does carpentry around here? Did we establish that last time? Who does a little bit of carpentry? Nobody? What standard plank of wood? A 2 by 4, but not centimeters, of course, right? Of course, it's inches. 2 by 4 inches. How big is a 2 by 4? What's the length and width of 2 by 4? No, I'm saying if it's called a 2-inch by 4-inch piece of lumber, what are the dimensions? No, what is it really though?
I mean, it's like a rectangle.
It's 1.5 by what? By 3.5.
Yeah.
It's a ½ inch less than what they describe. I have no idea why, but it is. I installed my own door in my house, and I was trying to find certain size lumber, and everywhere I looked, I'm like, I need 2 inches. Like, well, they're all 1.5. They all say 2 to 1.5. Well, this guy's an idiot. This guy's been working for all his life. If it says 2 inches, man, then you should be selling me a 2-inch piece of lumber. You're causing me a loss of money here. I'm buying extra wood, and it's not really there. But that's just the way the wood is. That's the way the wood is. I didn't realize it.
I think they cut it out. Yeah, and then they treat it. Oh, they don't.
It goes down by that much? That's a huge loss of volume.
Well, when it goes through the treating process, I think it drops. A lot of times it compact. It gets compact.
No. Really? I think they cut it to 1.5 because it's too perfectly 1.5.
I mean, that's because you can smooth. Just like you take a piece of lumber, like a raw wood, you can just press it down to it. You have to press a fine piece of wood. It's gonna lose.
Think so?
Yeah.
Maybe, I don't know. But all 2x4s are really 1.5 by 3.5. So keep that in mind when you need certain sizes for things. All right. Moving on to less practical things. So, in terms of the problem, if we call again, we have area and we have length and width. So, in terms of those letters, if we let A equal the area and L equal length, put some letters up here to find some variables, and W equal width, then in terms of symbols, what derivative are we looking for? It helps to figure out what symbols you want. So I would say it must be dA dt. If they just say the rate and doesn't say with respect to length or width or any other dimension they've given you, it's time. Okay? They want to know how fast it's growing. Right?
So
dA dt is what you want. dA dt.
So isn't that length? You take the derivative of length times width.
Okay, so we need the area function now. So we can differentiate with respect to time.
So
A equals, go ahead.
2 times 4.
Well, hold on, no, you can't put the numbers in. You gotta get
Length times width.
Right, length times width. So L times W. Okay. So we need the derivative of this thing. We need the derivative of L times W with respect to t. We need to take d dt on both sides. So I'm going to approach it from the implicit differentiation perspective. Take d dt of both sides, because I want dA dt. So if we do that, the left-hand side is certainly dA dt. And I have to be careful on the right, it is a product rule. Each of the length and the width are dependent upon t, right? They're changing with time, both of them.
If it's in respect to time, why is it dA dt, but there's no t in the equation?
So these are the problems that I thought you were going to have when we did implicit. You'd have a variable that's not in the expression. We never had any that complicated. So now we do. Both the first one we did and this one are having you take the derivative with respect to a variable which is not present in the problem,
Okay.
which is perfectly legit. It happens all the time. So we want this with respect to time. So even though it does not appear over here, it doesn't matter. You can still take the derivative of both sides with respect to some other variable. And time is the most classic variable that you'll do that for.
So it doesn't matter the variable?
Well, it does. We want to know how fast it's increasing. So that means with respect to time. Anytime it's about how fast, then it has to do with time, right?
Okay.
That's the only way anything happens fast in this world, right? It's because there is a thing called a flow of time. Otherwise, no such thing as fast or slow. No such thing as process either. No such thing as cause and effect, really.
Without time, there is no anything.
Yeah, everything would like happen at once or something.
No, without time, it wouldn't exist.
Well, why not?
Because everything's relative to time.
Really? Well, maybe God just make a world where there's only space but no time.
We wouldn't exist then, because space still needs time.
Why does it need time?
Because it's all relative.
Why can't it just be there? Why
If
does
it's
it
there,
change?
then it's in time.
No. If it's there, but it's just not changing.
But if it's not changing, that means the time is zero. You still need time because time is at zero.
What? Why need time? Hell with time. We'll just say there's just 3 spatial dimensions and call it quits. Right?
And what are
There'll just be this fixed universe. Pow! There it is. And it doesn't move. It doesn't change.
It's still in time though.
Why?
Because the time is at zero. Just because it's not moving, just because time's not going forward and backwards doesn't mean it's not there.
Oh, really?
Yeah. The time's at zero. That is that instant.
I don't know. I think it's. I don't know about that. I don't know. I think there has to be a flow of time for time to exist.
It's just like the functions we did.
Yeah?
The change of time or the change of direction was so instantaneous that we wouldn't be able to see. That's pretty much the same thing. At zero, it's that instant.
But if there's only one instant, there's not a bunch of instances. There's just one instant. That's all there is.
It's still at zero.
But you wouldn't perceive it. There's no. There's
Which
things
is
time.
why we can't exist without it, because if we can't perceive without the time, we can't exist.
Why not?
We wouldn't be moving. We wouldn't grow.
I agree. It wouldn't be the
And
same
nothing
kind
would
of
be done.
thing. We wouldn't be the same type of being. I agree. We'd be some sort of stagnant being.
We wouldn't get anything done if there was no
Okay,
time.
maybe there's nothing to get done. God makes a world where there's nothing to get done this time.
If there's no time?
But
Once you move,
No
that
time, nothing gets done.
No, there's no moving.
Nothing grows.
There's
Nothing.
It's
no
just stagnant. It's
moving,
just
there's no
pow.
process.
It's just stiff. It just. That's
Yeah.
all it
Oh,
is.
that makes
But
sense.
in order for you to think about it in the point of us being in that moment, you still have to think about the concept of time.
Yeah.
You can't think about something
Well, from
in
our
an instant
perspective now,
without-
looking and saying it's only a moment, yeah, you feel like there's time. I'm saying if all you were was that moment,
yeah, there's
there'd be no time, right? If all you were was that moment,